Hi, and welcome to our video on understanding Retrieval-Augmented Generation, or RAG, architecture. In this video, we'll explore the blueprint of this smarter AI. Think of it like building a house, but instead of using bricks and mortar, we're using data and algorithms. Let's dive right in. At its core, RAG has three main components: the retriever, the generator, and the knowledge source. The retriever's job is to find the most relevant documents. The generator then uses this information to produce coherent and contextually appropriate responses. And the knowledge source? That's the well of information providing the necessary context. To put it in simpler terms, imagine the retriever as an AI librarian, expertly digging through a vast library of books to find the exact one you're looking for. The generator is like a master storyteller, taking the information from that book and weaving it into the perfect answer. And the knowledge source is the library itself, packed with all sorts of domain-specific information, ensuring our responses are grounded and accurate. Together, they form an AI dream team. Let's walk through the process. It all starts when a user asks a question. The retriever immediately gets to work, searching for relevant information from the knowledge source. This retrieved information is then sent to the large language model, or LLM. The system then generates a response based on this retrieved data, and the final, informed answer is delivered to the user. So, how does RAG optimize the output of an LLM? It allows the model to access and reference information that exists outside of its original training data, such as an organization's private knowledge base. Here's a breakdown of the stages. First, in the retrieval stage, an information retrieval system, much like a search engine, is used to find relevant information from our library, the knowledge base. The output of this stage is the specific book or information we need. Next is the augmentation stage. The retrieved information is used to augment the LLM's input, providing it with crucial context and specific knowledge. This means the retrieved data is added to the user's original query and then sent to the LLM. The final stage is generation. At this point, we have an augmented prompt that contains the relevant context. The LLM uses this enriched input to generate a response that is more accurate, relevant, and grounded in the specific knowledge base. This response is then crafted, much like a storyteller would, and delivered to the user as the final answer. Now, let's visualize the logical architecture. The user's query first goes to the RAG module. In the retrieval stage, the system accesses the knowledge base, which can contain all kinds of data, structured, semi-structured, and unstructured. This data is stored in what's called a vector database. When the user's query comes in, the system fetches the most relevant information from this database. This retrieved text is then added to the prompt that will be sent to the LLM. So, the prompt now contains both the user's query and the retrieved text. In the generation stage, the LLM uses all of this context-specific, retrieved knowledge to generate a thoughtful and accurate response that is then sent back to the user. But how does the knowledge base actually work? Let's take a quick look. Imagine we have a huge document. We can't save the entire thing into the database as a single unit. So we chunk it. We break the document into smaller, manageable parts like pages. We then split the document and save each piece into the vector database in the form of embeddings. For now, you can think of embeddings as a numerical representation of the words. Each of these chunks is saved as an embedding in the vector database. When a user sends a query, that query is also converted into a numerical representation. The system then finds the chunks with the closest numerical values to the query. These retrieved chunks are then added to the prompt that is sent to the LLM. This has been a brief overview of the retrieval stage. We'll take a much deeper dive into each of these components and the strategies behind them in our next video. Thank you for watching. If you like this video, please give it a like, share it with your friends, and make sure to subscribe.